Now let's continue with example number 2 as part of our exercise for applying the law on indices. So you've seen how we solve number 1. Now we want to take the second one, x raised to power 3. So we'll go to number 2 now. So we have x to the power of 3, or x cubed, now to minus 2 over 3. We can rewrite this in this way by saying that 1 over x raised to power 3, 2 over 3. Remember the principle of reciprocal. So when it becomes the real denominator, we'll take away the minus. Does it look familiar? You want to try? Okay, what will you do next? We can apply the same principle we applied previously by taking a step further and say removing the bracket or parenthesis, x raised to power 3 multiplied by 2 over 3. And if we solve further, it will give us x raised to power 2. And that can be reversed into x raised to power minus 2. And that really helps us to see how this thing play out. This is 3 over 1 multiplied by 2 over 3. Let's go to the third example. There's one question I will ask you in the third example. 1000 to the power of minus 5 over 3. In most of the question on indices, you want to be able to ask yourself, no matter how big the number is, try to go between 1 and 9 or 2 and 9. That if what number can we multiply repetitively or repeatedly to give us this basic number? So as I'm looking at 1000, I'm asking myself, what would be the factor of 1000? That is, what number do we need to multiply between 2 and 10 in this regard? So I will start with 10, and this will be 100, and 10, this will be 10, and 10, this will be 1. So that means we have 10 raised to the power of 3. Now, I have 10 to the power of 3 raised to power minus 5 over 3. How do we solve further? We apply that reverse law of reciprocal. This will be 10 raised to power 3 and 5 over 3. So, can you help me from here? We apply the same law of indices, where we have k raised to power m, k raised to power m, n. And we can now say 1 over 10 raised to power 3 times 5 over 3. You notice one thing, we have 1 over 10 raised to power 5. And if you want to write the reciprocal, what would that be? 10 raised to power minus 5. Pretty easy? Very good. So you can practice all these exercises one after the other. Let's go to the fourth example. In the fourth example, you will help me out by answering some of the question. We want to find x. Remember, when we have x here, we are talking about the exponential power. So if 2 is here, they've given us a clue that we need to find number of 2's in 32. So how many 2's can we get from 32? In our previous example, we said we can find 2, I think, let's see, 5 times. Let's confirm. 2 in 8, 4, 2 in 4, 2, and 2 in 2, 1. And that becomes 2 to the power of 5. So we have 2 raised to power x and here 2 raised to the power 5. So we divide 2 on both sides by 2. So the 2 on both sides cancel out, and then we have x equals 5. And that balances it out. Now for number 5, look at question number 5. It looks a bit strange. We have 4 raised to the power x equals to 0.5. You might wonder, we didn't talk about decimal. We can also reverse. And how do we reverse? How do we get 0.5? By having 4 raised to the power x equals to 5 over 10. And that gives us 0.5 from decimal to fraction if we reverse it that way. So what is the common factor here? We have 2 raised to the power 2 x, and then we have 1 over 2. If we apply the law of indices, where we have k raised to the power n, (1 over k raised to the power n), this can become 2 raised to the power 2x and 2 raised to the power minus 1, applying the reciprocal. And if 2 whole number cancel on both sides, we have 2x equals minus 1. Since we are going to make x the subject of the formula, what do we do next? We'll say divide both sides by 2. So we have 2x over 2 minus 1 over 2. And here the 2 cancel out, and x equals half. Please practice this to polish your skill in indices. Please join me in the next video so that we can solve question number 6 and number 7, and I will introduce you to 2 more questions that will lead to quadratic equation. Thank you for watching. See you on the next video.